Welcome. I'm Deborah Byrd. We're EarthSky, and we are happy to be here today with the Bad Astronomer, Phil Plait. And many of you already know Phil. He's a veteran science blogger and has a knack for covering the most interesting topics in astronomy. So today we're going to be talking about the European Space Agency's mighty GAIA Space Telescope. Phil, welcome.
Thank you, Debbie. It's wonderful to actually see you again. It's been many years since I've actually seen you, and it's a pleasure to be on the show.
Well, we are so honored to have you. So when you and I talked about this beforehand, we both agreed we love Gaia. And so,
Yes.
Yeah. So can you tell people why you love it?
Oh, it's an interesting mission. It's not like Hubble or JWST or these other space missions where you get pretty pictures back and you can look at them and ooh and ah. It's a survey instrument, but it's what's called an astrometrical image mission. And what that means is it's actually measuring what sounds like a very simple thing: the positions of stars in the sky, their velocities, literally if they're moving towards or away from the Earth, or their velocity across the sky, their color, their brightness, and a few other things like that. The thing is, it's doing this for nearly 2 billion objects. That's billion with a B. And it's doing it at a precision that has never been done before. And what this allows you to do is a ton of stuff. You don't get images back, but what you get is data about all of these objects, the stars. And you're getting their positions super accurately, which means that you can get their distances. As the Earth orbits the sun, it looks at a star first this way and then this way, and that the star wiggles a little bit in the sky. This is called parallax, and we've been doing this for like 400 years, something like that. But Gaia is doing it to a precision that is just unprecedented, and so we're getting really accurate distances to stars that are even actually much farther away than we've ever been able to, and that's sort of the primary purpose. But what's actually happening is falling out of this is just a ton of other really cool science that you can do. And it is so much that it's actually hard to keep up with it.
Yeah. I mean, when I first started in astronomy, which was almost 50 years ago now, which is so strange to think of, almost 50 years ago, Astrometry I thought of as very unglamorous. It was like the most unglamorous of things, right? And now suddenly we have this space telescope that's primarily doing astrometry, measuring these distances, and then coming back and measuring them again, and then coming back and measuring them again. And by doing that, it's seeing these 2 billion objects, as you said, going across the sky. So it's been weird because it's not like Hubble where we're getting photos out. It's just data. And yet that data has given us like a more amazing picture in some ways of what's going on in our own Milky Way galaxy than some of the actual photos have. So tell me.
In a lot of ways, yeah. I mean, there's things you can do, of course, with taking photographs, images of the sky. There are other things you can do. There are other ways of analyzing starlight, but simply measuring the positions and the changes in the positions of these stars over time, it gives you a lot more than just their distance. And just getting their distance is really important, because when we first started doing this way back, and I'm not even sure when the first parallax was measured. I want to say it was in the 1800s. So it's been a couple hundred years. We started to understand just how big the universe is, because stars are really far away, trillions and trillions of kilometers or miles, if you prefer, away. As you refine that, you start to realize, oh, how many stars are close by? How many are far away? Is there a difference between stars that are close by and far away? It turns out there are. You can only see bright stars when they're far away. Faint stars you can't see at all. So there's a lot going on here, but then it turns out you can start to see structure in our galaxy. Now, if our galaxy were the entire universe and it were just scattered with stars everywhere, you would just see stars everywhere you look, and you would just see more and more and more as you look farther and farther away, because you're seeing more and more stuff. But it turns out it's not like that. Our galaxy is actually more like a flat disk, like your hand, like this. And if you were to see it face on, it would look like a big circle. Edge on it looks like more like a kind of a thick line. There's a bulge of stars in the middle. We have spiral arms around our galaxy, and we see lots of other galaxies like that as well. So we learn a lot about our galaxy just by seeing how far away stars are, and we can infer what the shape of the galaxy is. But there's more than that, because as you're watching the stars move, you can measure those velocities. You can say, oh, this star is moving a teeny bit in our sky, but it's really far away. So it's really screaming past us at like, a million miles an hour, some ridiculous speed. And you can start to learn about stars that way, like stars that are in the disk of the galaxy. How do they move around the galaxy? Stars that are outside, there's a halo of stars around us. How are those moving? We can measure the velocities of stars much farther away than we used to be able to. And on top of that, like there's ever a top to what Gaia can do. We can see motions of stars if they're actually two stars orbiting each other, what's called a binary star. That motion in many of these systems can be measured. It's hard, and you can't measure them too far away because the motion's too small. But as these stars are moving around each other, you see that in the sky, and so it can measure these binary stars. And if you do that, you can get the masses of the stars and all kinds of cool stuff. And if one of them is a black hole, you can figure that out too. And in fact, I believe there have been 3 black holes, including the closest one to the sun, that have been discovered because of Gaia data.
Wow, how close is it?
I don't know. 1,600 light years. I'd have to look that up.
Oh, so it's not like too close.
No, it's not like, a mile away.
Yeah.
They're called BH1, BH2, and BH3 in the Gaia data, black hole 1, 2, and 3. It's not very imaginative, but you can look that up and you can see that, we know that there are tens of millions of black holes like this in our galaxy, but they're black. They're hard to see, and you can only measure them. You can only detect them by their effect on stuff around them. If they're gobbling down matter, that material gets hot and very bright. If it's orbiting another star, it may be pulling down material from that star and again blasting out radiation. But if it's orbiting another star, it's not producing any light, and you can only see it by the motion of that star. And a few have been found that way, and a lot more are going to be in the next few years, I'm sure.
Okay, so Gaia is helping us find objects that we didn't know were there before, like black holes. And what else? What else is it doing?
What else? Where do I even start? One of the surprises that came out of Gaia is that as stars, more and more distant stars, all over the sky, mind you, are being mapped, they were finding stars that appeared to be moving in the same way. They're moving at the same speed and in the same direction in the sky. And they started calling those stellar streams. Now, it's not like you see a line of stars in the sky. Some might be in that part of the sky, some might be in that part of the sky, because we might be in the middle of them. Most of them are far away, and so when you map them on the sky, you see them in a line. And yeah, they're stars all moving in the same direction. And why would they do that? And it turns out there are several reasons. One is that stars tend to form, well, stars do form in gigantic gas clouds. So you can get lots of stars forming together. And those stars can all be bound together gravitationally, which means they all kind of orbit each other in a cluster. Now, over time, the gravity of the galaxy can pull that cluster apart. And when it does that, it stretches it out and it becomes like this line of stars that then orbit us. So you wind up finding these clusters that are old and torn apart by the Milky Way. We know of lots of clusters. You can see them in the sky. You see a picture of one, you go, oh yeah, a bunch of stars all in one spot. These streams aren't necessarily obvious at all, but they pop right out of the Gaia data, and there are lots of them. And as they studied them, some of these stars were really old, and they realized that what we're seeing are leftover remnants of entire galaxies that our Milky Way is eating. We're in a big galaxy. There are lots of little galaxies, and if one gets too close, our galaxy pulls it apart like taffy and eats it. And the remnant stars of that galaxy can still be moving around inside of ours. And then
that's so cool.
there's more. There are these globular clusters, which are a few dozen light years across, so small compared to the galaxy, but big compared to us. But they might have up to 1 million or sometimes even more stars packed into that small volume. So the nearest star to the sun is Alpha Centauri, the Alpha Centauri system. There are no stars between us and that system. In a globular cluster, there would be tens of thousands of stars between us and Alpha Centauri. So these things are really packed tight. We thought they formed with the galaxy, but it turns out some of them are also showing these streams of stars being pulled from them. Our galaxy is eating them. And what we've learned over time, not necessarily through Gaia, but it helps, is that some of these clusters aren't clusters at all. Those are the cores of galaxies that our galaxy has eaten. And one of the reasons our galaxy is big is because it's a cannibal. It eats other galaxies, and it eats these globular clusters too, and that's how it gets bigger. Weird.
Wow. That's so cool. I mean, I think what's the most amazing thing to me about Gaia and why I love Gaia so much is that, it's the same thing as when we went to, say, Jupiter and Saturn and Uranus with the Voyager spacecraft, and we saw them in the sky, and they were these blurry objects, and, Jupiter had bands across it. And then when we got there, it was just this super intricate thing with all these swirls and whirls, and it was just so much more detail than we had imagined. And the same thing is showing up in our galaxy with Gaia. We're getting so much more detail than we had before. So tell us more.
Yeah.
What other cool stuff is there? I mean, I know there's if you search for Gaia at EarthSky, you just get all these articles about discoveries that have come out of Gaia. I mean, it's really not like anything else. It's just been so amazing. So tell us what else.
Yeah. I mean, I've written about it so many times, I've lost track of it. And if you search on my newsletter, for example, or if you go to my old blog on sci-fi.com, I've written about it so many times. And it's because it is such a workhorse. It is such a basic thing that it's doing, that it's not just, oh, I want to study this gas cloud, I'm going to look at it this way and do these. You really, it's just a playground of data, and you can do so many things with it, limited only by your imagination and what the data show you. So, for example, there's a relatively famous star among amateur astronomers. It's a naked eye star, and it's actually up in the summer, so you could go out tonight and look at it. It's called Albireo, and it's in the constellation of Cygnus. Cygnus is the Northern Cross, and the brightest star in Cygnus is Deneb, and it's one of three bright stars called the Summer Triangle. So it's really obvious, this constellation. And Albireo is at the other end of the cross. It's than Deneb. And it's an interesting star because through even a small telescope, you can see that it's two stars. One of them is red and one of them is blue. The color contrast is actually very striking. It's one of the most striking stars in the sky because of this. Whenever I show it to people through my telescope, they're always like, "Ooh, you expect stars to be white, and these two are not." And the red and the blue contrast beautifully. And the thing is, they're pretty close together. But if they are at the distance that we think they're at, they're actually pretty far apart. And it's unusual to have two stars of roughly the same brightness be so close together in the sky. Just the odds of that are pretty low. So it's like, we'd assume that they're together, but you can't really assume that, and they're really far apart. So are they bound together and orbiting around each other? And I remember right after Gaia released its first data release, it said, okay, here's all this data. I posted about this on social media, and a friend of mine who was an astronomer picked it up and said, well, let's take a look. Let's go to the data. And then he's like, oh, they're not together. You know what? This story takes a lot of twists and turns because, you know, I'd literally have to look it up. I'm sorry. We had a software issue before starting this, and I was going to look that up right before we started all this, but I didn't get a chance. It's gone back and forth a lot because it turns out that the two stars don't seem to be moving in the same direction in the sky, so that kind of implies they're not together. On the other hand, there could be a third star in the system, which does imply that they could be together. He's posited that it's potentially possible there could be a black hole in that system, which seems unlikely, but we don't know. And it just, the more you dig into the data, the more complicated the system becomes. And I was so happy when the first result came out, and I was like, oh, we have our answer. And then he was like, wait a minute. And so what's happening is we're just finding out that this star is even more interesting than we thought. And that fills me with glee because this has been argued about for decades. And with Gaia, we will eventually get the answer because it keeps looking at these stars over and over again. It's been doing this now for over 10 years. it's going to keep doing it until it can't do it anymore. And the longer you look at these stars, the more, the more they move in the sky, and the better you can observe their motions. So hopefully we'll have an answer about this star system, because it's one of my favorites. And sort of the other thing is that there's this cluster called M73, and this has been known for a couple of hundred years, but it's just a few stars. And the guy who first made these measurements, Charles Messier, that's where the M comes from, the Messier catalog. He cataloged all these interesting things in the sky, and he cataloged the star cluster. And ever since, everybody's been like, "Is there really a cluster? It's like 5 stars." But they're all kind of the same brightness and close together in the sky. So, maybe. But no, with Gaia, we found out that they're at all different distances. And so they can't possibly be together. We're seeing them like this. You've got one star here, but one star here. They look close together, but as you can see from the sizes of my thumbs here, this one's really close to you and this one's really far away. So by measuring the distances to these stars, we realize, no, M73 is not a cluster. So it's answering like super basic questions like that. And I think that's really cool.
Yeah, and it's like with Albireo and M73, that's so cool because those are very well-known objects. I mean, those are like beloved objects in the sky that we've all known about for decades. Well, I mean, our whole lifetimes as amateur astronomers. So that's so cool. So let me tell everyone we're talking with Phil Plait, the Bad Astronomer, and Phil, you've got an awesome newsletter that I get and that I really just love, and you really do have.
Thank you.
Yes, I really think it's great. I'm going to pop the how to get your newsletter up on the screen. So that's one way to get it. You can also just search for Phil Plait, Bad Astronomer. Can you see that, Phil? There's a badastronomy.beehive.com address.
I don't see that on my screen, but I'm using the mobile app, so who knows what's going on here.
Yeah, well, hopefully it's up there.
Hopefully somebody else needs it. And I'm looking up Albireo now, trying to find what I said about it.
Yeah. But if you would like to get Phil's newsletter, then you can also just do a search on Phil Plait, Bad Astronomer newsletter, and it'll give you various choices on how to get that. So it's very enjoyable. It's just a lot of fun to receive that. So Phil, what else? What else is new and cool in your world?
Oh, I just looked up my articles on GAIA on Albireo. You can just look them up online. You'll find them. Gosh, what's new? Everything, so much. Exoplanets, planets in our solar system, the moon, the sun. Because this is EarthSky and we're live, I'll mention that there are 2 naked eye sunspots on the sun right now. The sun is approaching its peak in its magnetic activity. This 11-year cycle you may have heard about. The sun has this magnetic cycle where the magnetic field strengthens over time and then weakens over time, and we're approaching the peak. And so there are lots of sunspots, which are a magnetic phenomenon, and they can get really big. And I saw one the other day, and I was like, oh, let me look that up. And yeah, sure enough, you can see it online. It's this enormous sunspots, way bigger than the Earth. And if you still have your eclipse glasses, which I hope most of you do from April, pop those things on and look at the sun. Remember, don't look at the sun with just your eyes. Don't use binoculars or anything like that. But if you have eclipse glasses,
don't use binoculars.
Yeah, definitely not, unless you want to burn a hole in your head. But but I was out yesterday. I have a big filter for my telescope, my telescope right there, and it makes it easy. I can just hold it up and look at the sun. And yeah, the one sunspot's really obvious. The other one's a little bit tougher. It's near the edge, but I could definitely see with my own eyes without any optical aid besides that filter. So that's pretty cool.
Yeah, EarthSky has a daily post on. Let me pop up our address. We have a daily post on Sun News. So what we're showing here is for night sky news, and more visit earthsky.org. So one of the more things there that you can get at EarthSky is a daily post where heliophysicist C. Alex Young writes that post. I think you know him, Phil. He said he knew you. I think you guys were at Goddard together at one point. And
long time ago. Man.
Long time ago. Yeah. And so he and Raul Cortez work together with a whole team of people every morning to get the sun news out. And we talk about things like those sunspots that Phil was just mentioning. And yeah, it's really cool. It's been really amazing this year, the activity on the sun. And this past weekend, in fact, last night was an amazing night for auroras because we had some coronal mass ejections that hit the Earth. So that's a very cool thing. So
not where I live in Virginia, sadly, but if you're up farther north, yeah, it's been pretty exciting.
Yeah. And, we had that big event in May where I think, I mean, I know for sure that there were auroras seen as far south as Virginia. So because they saw them even as far south as where I am here in Austin, Texas, although I didn't see them. But
me neither.
Yeah, but lots of people did. So, so what else can you tell us about the Gaia? Discovered some, looked a little closer to home. Just last week, they were talking about how it discovered the possibility of some additional moons for asteroids in our own solar system.
Yeah, that's another thing. I mentioned the binary stars. As two stars orbit each other, their gravity, right, pulls them into orbit around each other in circles. It could be, ellipses like that, but both stars are moving. This happens with any two objects that orbit each other, and how much they move depends on how much gravity they have. Well, it happens too with asteroids. Asteroids have moons. Now, we're talking about objects that are not terribly big. The largest asteroids in our solar system are still way smaller than our moon. But even the small ones can have even smaller moons. So some of these objects are just a few hundred yards, meters across, and they might have a smaller moon orbiting them that might be the size of like a football stadium, a couple of hundred yards across. But as they move, as we look at them like through a telescope, we can't separate them. They're a few hundred yards across, but they're millions and millions of miles away. So they appear as a single dot in a telescope. But as Gaia looks at these things over and over and over again, if the asteroid has a moon orbiting it, and you don't see the moon because the moon is very low, very dim and very low mass, it doesn't have a lot of gravity, but it has enough to make the bigger asteroid wiggle a little bit back and forth as it moves across our sky. And so you see this sort of wavy track as the moon of the asteroid pulls the asteroid around. I wouldn't have thought that would be measurable. How much could that possibly be? And it turns out it's enough. Gaia is so precise that it can actually see the wiggle, statistically, the wiggle of this asteroid as it's moving across the sky, which is exactly what it's done with binary stars. And in fact, stars besides the sun have planets. We've seen thousands of them. Gaia can actually see the motions of stars as their planets orbit them because the planets have enough gravity to make the stars wiggle as they move across the sky. Again, I wouldn't have thought that's possible, and yet it has been done. Again, because of Gaia's incredibly accurate measurements of these objects.
Yeah, and so, it's like Gaia is measuring these things on these huge scales of these stellar streams moving across the Milky Way galaxy, and it's also measuring things on these little bitty scales of these tiny little asteroids that are orbiting around each other. So that's very cool. We've got a question from a viewer, and that is Lek Kaniuk. I'm sorry if I'm mispronouncing that. I probably am. Wants to know if Gaia can be used to help us understand dark matter.
Yes, in fact, it can, because we think there is a halo of dark matter around our galaxy. Our galaxy has hundreds of billions of stars in it. It's a very massive object and a lot of gravity. And we think that when it formed with a lot of dark matter as well as normal matter, like what we are made of. The problem with dark matter is you can't see it. All you can see is its effects on normal matter. So it has gravity and it pulls on things, and you might be able to detect that. In the case of our entire galaxy, we're surrounded, embedded in this giant sphere of dark matter. We're not sure if it's spherical, it might be, might not be. But it's affecting how stars move in the galaxy. This is how dark matter was actually originally discovered, is its effect on the motions of stars as they orbit around the centers of galaxies. And it might be affecting ours. And if it is, that'll show up as we measure more and more what we call space velocities. Sounds like something out of a bad movie from 60 years ago. but it literally is the velocity of stars through space that we can measure. It will have an effect on that, and you can measure that, and that'll help us not just detect dark matter, but maybe let us know things like, is there more dark matter toward the center of the galaxy than farther away? Different models of how dark matter behaves. Some of them argue that, yeah, it's evenly distributed everywhere. Other places have it much denser in the center of the galaxy. Maybe we can use that to distinguish between these models. I don't know if Gaia can do that, but if you give it enough time, if it keeps working for 100 years, we'll see so many stars and their motion so accurately. I think we'll be able to pick up stuff like that.
Yeah, or they can launch Gaia too.
And they should. Gaia is not the first satellite to do this. We did this from the ground for years. And as a matter of fact, the University of Virginia has a telescope that used to be dedicated to that. There was the Hipparcos satellite, which was also a European mission, and there was one before it. I'm blanking on it. Hipparcos might have been the first that was dedicated to this, and it got good measurements, and it really helped. And Gaia is just so much better, and it's still 15-year-old technology. If we were to build a new one today, it might be a lot better.
Yes, it's amazing how things just keep getting more detailed and more detailed and more detailed. Yeah. That's been an amazing thing. So Phil, thank you so much for joining us today. It's just been so much fun to talk to you, and you just know so much about so many things. It's awesome.
Well, thank you. You know what? And it's fun to hear your voice, because I'm so used to hearing it in my car. To actually see you, and it's like, oh yeah,
it's like.
So I'm enjoying this a lot. Thank you.
They sync up. Yeah. Yeah, and what Phil's referring to there is that EarthSky was on the radio for just a long time, and we are no longer on the radio. You may not realize that. Yeah, we've been off the radio since 2013. So
I should say I used to listen to you on the radio all the time. Yeah. Yes. Now it's the podcast.
Yes. Well, I hope you will join us again sometime to talk about more, because when you and I were first talking about this, I know we discussed the subject of lunar lava tubes, which I personally think is like one of the most interesting topics ever.
It's cool.
Yeah, very cool. And tough to get them all in, like any of these. I noticed today in the news.
I warned you that I can't.
You did.
Stop talking about stuff, and we're never going to have time to talk about all the stuff on our list.
That's right. And today in the newsletter, you were talking about dark comets, which we had a short on dark comets, and we're also going to be speaking with, I can't remember her last name. I think it's Tyler. I can't remember the researcher's name. But anyway, they are very cool, and they came up with the idea of dark comets. So watch for that at EarthSky. Thank you, Phil. You've been watching EarthSky, and my guest has been Phil Plait, the Bad Astronomer. And just thank you. It's just been great. So please tune in again next Monday, when I'll be talking with David Schiffman, who is the author of Why Sharks Matter, about those imperiled and elegant ocean guardians, as he calls them. So should you be scared of sharks? Come find out next Monday. Thanks for joining us, y'all.